In this video, we'll continue our discussion of Python data structures by talking about the tuple. This video will probably be, or the rest of the videos in this lecture series will probably be shorter than the first one, since we'll be using a list as a basis for comparison for other data structures. A tuple is extremely similar to a list, but with a single major difference. Remember, lists were ordered, heterogeneous, and mutable. A tuple, on the other hand, it is immutable. We can create a tuple using parentheses instead of square brackets. Here we have an example tuple showing its heterogeneity and the fact that it's ordered. We have 4 different data types entered in as Dylan, 26, 167.6, and true. And they print out in the same order in a single data structure. Since a tuple is ordered, we can also access a tuple just like we did a list based on position. So if we want to retrieve the third element, or the element in position 2, we just use square brackets 2 after the name of the tuple. However, since the tuple is immutable, we can't change the value in position 2. If we try to do it, we encounter a type error, and we're told tuple object does not support item assignment. This is a consequence of tuple being immutable. We cannot mutate values within the tuple. Instead, if we wanted to change a value in the tuple, we would have to entirely reassign the tuple. So if we wanted to change this to 169.3, we would have to reassign example tuple to be equal to this new tuple, which works just fine. However, we cannot mutate the tuple by reassigning portions of it. Note that deletion, which is also a mutation, fails as well. Tuple doesn't support item deletion. All the mutations that we observed with lists, such as item deletion, sorting, item insertion, or appending new items, all of that will not work with tuples. You might be wondering then, what is the point of tuples? Why would we want to block ourselves from doing this? Remember that at the end of our discussion of lists, we mentioned that the mutability of lists involves some amount of danger. And we showed an example where changing A could change B, because A and B were names both pointing to the same list. And when we mutated that list, B updated as well as A. This can lead to confusing problems in your code where a mutated data structure is not in the state that you think it's in. Tuples help protect against this circumstance since they cannot be mutated. And in fact, in many cases, we will want data to be immutable. And our program will be a composition of functions which act in concert on immutable data. When we're creating a tuple, in fact, the parentheses are optional. We can create a tuple by simply having comma-separated values. However, it's good practice to include the parentheses for clarity in most cases. One place where it's common to not use parentheses is functions that return multiple outputs. Here we have a function called first last that accepts an argument s, which we'll take to be a string. It returns the first and the last character of the string. Note that when we call first last on hello and assign the output to cars, or chairs, depending on I guess how you choose to pronounce this. It's short for characters, so I'll say cars. When we print out the value of cars, we get a tuple, H and exclamation point, the first and last letters in the string. So when we have a function that returns multiple outputs, it returns them as a tuple. In many cases, we'll want to access these outputs as separate variables, not as a tuple. In this case, we can use a technique called unpacking. We can assign the output to multiple variables separated by a comma. So the first character will be assigned to this first variable, and the second character, or last character, will be assigned to this second variable. Now, we can interact with these outputs as separate variables. This will come up a lot, for instance, in iteration, and we'll see examples of that later in the notebook. Note, we can actually unpack any tuple, whether it's returned by a function or not. Remember, we initialized an example tuple with some information about me, and we could unpack the elements of this tuple into different variables by using the same syntax as above, but replacing the function call with just the tuple itself. Then we have access to this information as separate variables. Note, unpacking doesn't only work with tuples. We can also unpack a list. In general, we can unpack any container in Python as long as we provide the matching number of variables to perform the unpacking. If we don't, we may encounter something like the following. Here we got a value error that tells us too many values to unpack, expected to. In other words, Python expected to unpack the values on the right into only 2 variables, but since there's 3 values, it can't unpack them into just 2 variables. If the situation were reversed, where we had 3 variables for unpacking 2 items, we'd be told not enough values to unpack. Expected 3, but got 2. Here, Python is telling us that it expected to unpack values into 3 variables. It expected 3 values, but it only got 2. As mentioned, both the list and the tuple are ordered and heterogeneous, but the main difference between them is the tuple is immutable. If we want to represent data that's likely to change over the course of running a program, we might want to use a list so we can mutate that data as it updates. However, if the data is fixed, like some survey results, then a tuple might be better for representing the data. One mistake we can make regarding this immutability is assuming that the immutability applies to the contents of a tuple and not only the tuple itself. Here is an example where we have a tuple that contains a list. Here. We can, in fact, mutate this list despite the fact that it's inside of a tuple. Let's make this just a little bit clearer. We'll access the tuple at position 0 to access the list, and then we can use that list's append method to add or mutate the list inside. We can see that even though we have at the start a tuple containing an empty list, after appending to the list, the list in the tuple has mutated. So even though the tuple itself is immutable, the objects in it are not necessarily immutable. This concludes our discussion of tuples, and in the next video we'll talk about the set data structure.